Good afternoon, and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is Luca Turquette, musician, composer, computer scientist, teacher, and author. Works, workshops, and papers on a variety of topics related to music and sound, authored by Maestro Turquette, have attracted worldwide attention through the IEEE. IEEE is the Institute of Electrical and Electronics Engineers, the world's largest organization for engineering students and professionals, with more than 460,000 members in 92 countries. Please welcome Luca Turquette to the Music and Technology Seminar.
Hello, everybody. Thanks a lot, Ricardo. Thanks a lot, Roger, for having me here. It is a pleasure for me to share with you some of the results of my research on these exciting domains of the Internet of Musical Things and its evolution towards the musical metaverse. Today, we will talk about enabling technologies and open challenges. So first of all, what is the Internet of Things? It is a paradigm in computing which relates to the extension of the internet into the physical realm by means of everyday physical objects that are spatially distributed and augmented using information and communication technologies. The typical example is that of the smart fridge, right? Where it is we have a fridge, a conventional fridge, which is augmented with a set of sensors, an embedded computing unit that does some processing on these sensors, communicates towards an external device such as the smartphone, some kind of information. The smartphone can act as a proxy towards the cloud. Then many of these devices can bring their data towards the cloud, and then the cloud can provide back to the user some kind of other information in the form of some services. So things in the Internet of Things are essentially embedded systems that are connected together and to the internet and are able to interact with each other in order to reach some common goals. And the key point here is that these devices, each of them has some degree of the intelligence. But what about music? So in 2014, I started to work on this domain, and I noticed that there was essentially nothing. The application of Internet of Things technologies in contexts that were musical had received a completely little attention, essentially, compared to domains such as healthcare or domains such as vehicular technology, home appliances, and so on. But from that moment up to now, there has been an increasing interest both in the academia and the industry to bridge this gap between the Internet of Things and the domain of music. And indeed, in 2018, me and other colleagues arrived to a formalization of a vision for the field of the Internet of Musical Things that extends the paradigm of the Internet of Things to the musical domain. I have to remark one important concept. We are talking about a vision, not an established paradigm, but also the general field of the Internet of Things is not an established paradigm today. If you want a quick definition, what is the Internet of Musical Things? Is the network of physical objects that we call musical things that are dedicated to the production, interaction with, or experience of musical content. It is a really interdisciplinary research area, merging music technology, networking, embedded systems, artificial intelligence, human-computer interaction, security and privacy, semantic web, multisensory perception, of course, music studies, and also humanistic domains such as the field of ethics. It's an emerging area, very, very interdisciplinary, as I mentioned, and very exciting to work in this area at the confluence of humanities and technology. In the Internet of Musical Things, there are the musical things that are the counterpart of the things in the Internet of Things. But what they are? Well, a musical thing can take the form of a smart musical instrument, a wearable, or any other smart device that is utilized to control, generate, or track responses to musical content. You can see some examples here, from a smart guitar to even a smartphone used for musical purposes, smartwatches, or even, as we will see, head-mounted displays. What are the main technological components of this paradigm? Well, first of all, embedded audio systems, which are embedded systems in terms of hardware and software, dedicated to low latency audio processing and low latency sensor processing. Then we have, of course, AI, both in terms of machine learning methods, but other kinds of AI systems, such as semantic web. In particular, we have also the case in which this artificial intelligence can run offline, but also in particular in real time. And the point is to run these artificial intelligence methods that we will see in a bit, not only on the cloud, but also on these embedded systems. And then the last component is the network infrastructure. Here we are dealing with both wired networks, but also in particular wireless networks, in particular 5G and 6G technologies. And these networking infrastructures enables a set of services such as network music performances. But most importantly, thanks to the Internet of Musical Things, it is possible to devise the so-called ecosystems, digital ecosystems that are typically composed by three components: the musical things, of course, that are used by the stakeholders, the connectivity infrastructure, connecting the stakeholders through these musical things, and then a set of application and services. These ecosystems form around given Internet of Musical Things technologies, but not only technologies, also communities of users that use these technologies. And there are a number of stakeholders that are interested by this paradigm. Performers, live sound engineers, students, teachers, of course, audience members, but also publishers, recording labels, concert venues, and so on. Now, I would like to share with you some examples of musical things, and in my research, I proposed the class of musical instruments that I termed smart musical instruments. And to introduce them, I would like to share a video, and I hope that it works. So please give me some feedback about if you hear any sound now. Do you hear?
Yeah, we can hear the sound.
Fantastic. Then let's see this video. That is a smart guitar that I contributed to develop when I was part of the company that I co-founded. It was active part. Now I'm a professor. So this is the Sensu Smart Guitar. Right. So this is an example, one of the first examples of a smart musical instrument, as we call it. So what is, as you can see, it is a guitar, but it's not a guitar. So it comes from, of course, the tradition of the NIME community of augmenting instruments with sensors and actuators. But the key point is that the instrument has a brain. There is an embedded system inside it, and which make the instrument itself a true Internet of Things device, because there is onboard processing of the sensors, but there is also the possibility of communicating information towards external devices using telecommunication infrastructure such as Wi-Fi, Bluetooth, and at that epoch, we are talking about 2016, 4G. We can stream audio signals, MIDI messages, open sound control messages, and this is all achieved thanks to the embedded intelligence that is indeed integrated in the instrument itself. So let's talk a little bit about embedded systems. So it is important, an important component of the Internet of Musical Things, because is essentially the enabler for creating this kind of musical instruments and beyond. So other kinds of musical devices. So the musical things, sorry, are developed thanks to these systems that are essentially single board computers, from the Raspberry Pi to the Jetson to other systems that now integrate in a unique solution a single board computer with a sound card such as Bela or the Elk audio platforms. And the peculiarity, however, of these devices, these platforms, are that they enable the processing of sound and sensors in really low latency and at the same time they offer libraries, modern libraries, to connect wirelessly towards a plethora of external devices. And this now in 2025 is somehow something that we take for granted, but when I started working on this domain, Bela didn't exist. The Elk audio operating systems that I contributed to develop together with the Elk audio company that I co-founded did not exist. So we had single board computers that needed to run a Linux operating system and that needed to be patched in order to achieve real-time performances. So nowadays, the development of smart musical instruments is greatly facilitated by technologies that are available today, even open source. Thanks to these systems, it is possible to devise novel services for musicians based on technologies such as real-time recognition of expressive feature of the music played, say tempo, emotions, or even playing techniques, and going further, some high-level attributes such as a set of predefined musical patterns, as we will see in a bit. And of course, one needs to develop software relying on machine learning libraries that are tailored for these kind of devices, and not just for conventional computers, which pose particular challenges because we are dealing with real-time operating systems. But I mentioned that we can create, thanks to these technological enablers, musical instruments that I termed smart. But what does smart means in concrete? And in the industry, in the academia, looking also back to my initial instruments, well, I have to say that these instruments were not really smart. So I tried to define the notion of intelligence for this class of musical instruments and identify the intelligence in terms of 5 capabilities. The first is knowledge management, which means that these instruments are capable of maintaining knowledge about the instrument itself and the surrounding environment. So this is the concept that is central to the Internet of Things, of context awareness, which imply the need of models that need to embed in the instrument, that give the opportunity to the instrument to understand the instrument itself, or to model the musician playing the instrument itself, but also the model of all the connected devices, because we are dealing with the smart musical instrument that can talk with a plethora of other connected devices that we call indeed musical things. But then, based on the knowledge that is acquired, the second capability is that of reasoning on the acquired knowledge, and this can be done in a real-time fashion or offline. In real time, of course, we can think to systems for music and methods for music information retrieval. Another aspect of reasoning in this context is that of musical instruments that are capable of exploiting the intelligence that is present in the network. So we can leverage the intelligence of other connected musical things, other devices connected to the musical instrument, but also leveraging the intelligence of the cloud, or the distributed set of systems that form the edge cloud continuum. Today, however, to implement these two capabilities, there is the need of creating novel models for knowledge representation, and I'm talking about the domain of semantic web with ontologies and inference mechanisms on databases that indeed enable the modelization of the instrument, the musician, and the connected devices. The third capability is that, of course, of learning. So we are dealing with machine learning methods that enable the musician, the musical instrument to learn from the previous experience of the musician interacting with it, which means the interaction in terms of playing, but also the interaction in terms of connecting the instrument itself with the devices, especially in wireless fashion. And then the fourth capability is that that relates to the interaction, an enhanced interaction of the musical instrument with the musician. So this kind of smart musical instruments, in my vision, will be able to adapt to the context, which means adapting to the musician or to the surrounding environment, and also to provide some kind of proactivity, some proactive abilities such as recommendations in an automatic manner. To achieve this, of course, we need a plethora of new artificial intelligence techniques, especially for the real-time case, which is a topic which presents really a set of open challenges. One of them is, of course, the adaptation of these AI methods on embedded systems, and the adaptation of these methods for the interaction of the embedded system itself and the edge or the cloud. The fifth capability that a smart musical instrument, in my opinion, should have is that of enabling the interaction between the instrument itself and the devices. And this means that the musical instrument can exchange in real time information in a bidirectional way between, for instance, the musician and the audiences, back and forth. And this opens really novel types of applications that would not be possible without this kind of paradigm of the Internet of Musical Things, encompassing musical instruments that can indeed communicate with the external world. So let's give some examples, some concrete examples of this kind of applications and services that can be created thanks to this paradigm. One of that is, of course, the real-time control of stage equipment through the real-time processing of the musical signal as the musician is playing. So to illustrate you this scenario, I would like to share a video where a smart musical instrument is conceived, this is a smart guitar, to control wirelessly stage equipment such as smoke machines, stage lights, and so on, by means of the recognition in real time of predefined melodic patterns. Right. So in this video, we showed that the instrument itself was running this kind of artificial intelligence that was following the act of playing of the musician and recognized, in this case, one pattern, but we arrive up to 10 patterns. Right. Another application we'd like to talk about is that of a smart musical instrument which is able to perform a query to a repository of music. So imagine a repository like YouTube or Spotify or Apple Music. What you do if you are a musician and you want to practice? Typically, you would search for some backing tracks or for some kind of music that you would like to rehearse as a guitarist, some solos, or track some kinds of chords and play over the chords and recognize the chords and so on. Therefore, what we did, we exploited the paradigm of the Internet of Musical Things in order to enable musicians to query this kind of repositories, not just by the textual queries that one could do. So, for instance, using as prompt as a prompt the name of the artist, the name of the band, but querying the repository by the act of playing. So the intelligence embedded in the musical instrument will recognize in real time from a musical excerpt the tempo, the key, the emotion, and so on, and will stream these messages, these keywords towards the repository, which will be indexed across the same matrix, and there will be a match between this matrix and the music that is contained in this repository, and therefore the musicians will get back to the instrument itself the music corresponding to what he or she played. And by the way, the musical instrument, you can see in this picture, is equipped with a loudspeaker, so there is an automatic then playback of the music retrieval. Musicians really appreciated this concept in user testing that we did with experts, intermediates, and beginners. But there are other classes of musical things. The one that we'd like to talk now is that of musical haptics, musical haptic wearables. So these are devices that encompass vibrotactile stimulation, for instance, that can be used for two purposes: to enhance creative communication between musicians or between musicians and audience members, and also to enrich the musical experience of listeners, of audience members attending musical performances. And this can be achieved both in co-located settings where musicians and audiences share the same physical location, but also remote settings, which means over the internet. So I go quick here, but I would like to share with you an example of what I mean. This is, as you can see, a device encompassing some buttons, an embedded system within it, and here you can see some vibrotractile motors. And we used this system to solve an issue because electronic musicians in particular, when they play together, they are completely buried in their tools. So they do not, they tend to not look at each other when they play, even in concert. And this prevents the communication, so that there is not a visual link. So a visual communication is not feasible because even if one of the two musicians is saying, hello, please look at me, I want to change the tempo, please change the tempo yourself as well. Well, this communication is not feasible any longer. So what we did, we exploited the Internet of Musical Things paradigm to provide wirelessly a notification to musicians in order for them to capture their attention, or even to avoid them to even look at the other musicians, but to respond with some actions that have been agreed beforehand, indeed in response to a certain type of vibration. So this is the device. Here we have a musician. This is the conductor on the left. Here is another performer. In a bit you will see, there you go, that the musician has pressed a button on the musical haptic wearable and wirelessly sent a message to the other musician, which will feel a certain vibration pattern, and the vocabulary here was that at this particular vibration, the action was to change the music, and if you are listening, there is indeed a change of timbre and structure of the music. And then the video continues. If you want, you can see it online. But this kind of paradigm is in particular interesting for tactile communication among visually impaired musicians. Indeed, we tested the same concept with an orchestra of visually impaired musicians, and we found that indeed this kind of interconnection at the tactile level was really effective for supporting the musicians in their process of synchronizing, and also to perform other kinds of musical tasks that for people with normal sight are trivial, but for people that do not see are pretty complex, because they are typically based only on their auditory system, such as, for instance, changing the tempo or stopping, crescendo, decrescendo, and so on. Another kind of usage of these kind of devices is that of enhancing the musical experience with a tactile representation of the music. Here in this short video that I will share with you, still you can find it online, the musician, actually myself, was using as smart mandolin equipped with the sensors, and there was also some kind of music information retrieval system going on in the background, and in real time informations from the gestures of the musician and from the musical signals were streamed to the audience wearing some kinds of wearable devices on the torso that provided a tactile layer, if you want, additional to the music heard. right? So when the musician was hitting on the instrument, on the pressure sensors on the instrument, there was a percussive sound triggered, and at the same time that this percussive sound was triggered, the audience members were receiving an impulse vibration on their torso. So the experience was pretty immersive according to the feedback that we got. But then we can't talk about the Internet of Musical Things without dealing with one of the cornerstones of this paradigm that is represented by network music performance systems, which are systems that enable geographically displaced musicians to play together. And the goal here is to play in a realistic fashion over the network, which implies solving technical issues such as low latency and high quality in the content that is streamed across musicians. So to clarify, there we go. There is a box here, an embedded system. They're connecting these two musicians. Them are also a camera. The system that you can see is audio visual, meaning that there is a stream of the audio in ultra low latency, but there is also an accompanying video, which is however bidimensional. What is crucial, what is difficult here? The difficulty here is that to enable this kind of performances over the network, one needs to cope with the latency requirements of musicians, which are pretty strict. We are dealing with 30 up to 30 milliseconds. Otherwise, musicians above 30 milliseconds of latency start to have an experience that is deteriorated because they can't synchronize any longer. This has been proved by a plethora of research in this domain. But also musicians need that this latency is kept constant, and also that the quality of the sound that is transmitted is sufficiently high, which means that the network needs to be reliable with a few packet losses. But most importantly, a new avenue for these systems is that of trying to or aiming to recreate the realistic conditions so that musicians at the aural level have the impression of sharing the same physical room. Now, in my research, I tried to bring these systems that originally were conceived for wired networks towards the realm of wireless systems, in particular 5G networks. So a big deal of my research has consisted in integrating network music performance systems into 5G architectures. First, I tried to simulate these 5G architectures and applications, and then I designed actual deployments, and I tested the performances across metrics such as latency and reliability. This is one of the pictures of the system that we deployed. You might think that this is not a wireless study, because all the wires that are on this table, where we connected 10 nodes to a 5G system, for a 5G base station. And what we found that yes, we could achieve an exchange of audio content across this state-of-the-art 5G testbed. We achieve latencies in the order of 24 milliseconds between one node and the other, with packet losses of a probability of 0.01. The key consideration is, yes, 5G can support audio-only network music performances, but really the latency and the reliability really need to improve, and there is a lot of work to do in this domain. But to conclude this first part of my talk, I would like to summarize what are the implications of all I said before. So first of all, thanks to the Internet of Musical Things, it is possible to reimagine certain musical activities such as live music performance, but also composition or music learning. Second, the Internet of Musical Things technological ecosystem multiplies possibility of interaction between musicians, audiences, audio engineers, students, teachers that use dedicated musical things and services. And also we saw that the sonic content can be augmented with other modalities such as vision or touch, and this can be achieved in real time. All these, in my opinion, has the potential to create a revolution in the way music is composed, music is performed, learned, taught, experienced, and even recorded. But let's take a step further, because these kind of musical things can also take the form of head-mounted displays. So imagine the situation in which the audience not only wears the haptic vest that I was mentioning before, but also can wear this kind of extended reality devices and have an experience of mixed reality where the musician control via the smart musical instrument some kind of virtual elements that are seen by the audience. But also we can consider the case of virtual reality, where geographically displaced musicians do not just play in real time over the network, relying on audio-only interconnectivity, or at most audio-visual connectivity based on bidimensional videos, but being fully immersed in a virtual reality environment. So this step further that I'm taking is a step further towards the metaverse in its musical flavor. But what is the metaverse? The metaverse, despite big claims of tech giants such as Meta and so on, is something that is that does not really exist today. Is still a vision that relates to a set of interconnected virtual digital worlds which are parallel to the real physical world, where each user owns and interacts via an avatar. And there are a variety of technologies contributing to this vision. In particular, we are dealing with collaborative virtual environments or mixed reality environments, but also, of course, networking and the Internet of Things, multimodal tracking, multisensory rendering, AI, blockchain, digital twins, and so on. And in these virtual spaces, it is possible to perform various kinds of activities, from training to shopping to healthcare. One of that is, of course, music. But what is the state of the art of musical applications in the metaverse? Are concerts, virtual reality concerts, such as this one. Let me share a video. Okay. Audience members are wearing an head-mounted display and see this kind of visualizations. There is a DJ. And what is the state of the art? The state of the art is that this DJ essentially is not playing live typically, is instead an experience of streaming, where there is a musician on this virtual stage streaming music to the audience. And the point is that that there are not really proper social interactions between performers, or between performers and audiences, or between audience members itself. But still, there are great business opportunities. These kind of concepts have attracted famous artists and also a great deal of sponsors. But what about music making like we know it in real environments? Well, there are a number of musical activities that can be performed in these spaces which are essentially collaborative musical activities such as collaborative composition, education, recreational music making, rehearsals, and so on. So it is possible to envision this kind of activities in these spaces, and this led me to formulate a vision for the musical metaverse, which is based on two kinds of the technological enablers. One is, of course, the Internet of Musical Things, and the second is the domain of Musical XR. Musical XR is a field that is positioned at the intersection of interactive music and extended reality. We are here dealing with audio-first experiences, encompassing musical instruments that exist only in virtual spaces, for instance, and of course, musical environments that are available in virtual or mixed reality. However, from a survey that I conducted on this domain, I noticed that even today, the vast majority of the applications in Musical XR are for single user. But music is mainly a social activity, right? So again, we have some issues. What are the technological gaps that prevent the fact that multiple users can share these virtual spaces and interact musically like in the real world? Where to address these issues, I first of all tried to define the musical metaverse, and here you can see a definition, but I would like to focus on a three-layer framework that could be applied as indeed as a general framework to try to implement applications that indeed enable social immersive musical experiences. So at the bottom, we have a physical layer where we have the real world. So musicians, real audiences, but also the virtual musical service providers, the physical musical service providers, and of course, the musical instruments or the musical things. Then we have on the top the virtual layer, which are the avatars for each of the musicians and audience members. We have the virtual musical environments, and we have a set of virtual musical goods and virtual musical services, such as NFT, for instance. And then in between, what enables the synchronization between the virtual layer and the physical layer is a link layer, which is the Internet of Musical Things infrastructure, coupled with, of course, data integration and storage components, cloud computing, and so on, where it is possible to provide all is needed to have feedback from the real world, sensing data from the physical world and having feedback from the virtual world back and forth. And this is essentially accomplished by a so-called musical metaverse engine, which is composed by musical XR applications, digital twin, again AI, blockchain, and so on. But we also tried to take a perspective that goes well beyond the technologies themselves. And applying human-computer interaction methodologies, we asked musicians, what do you need? What do you desire? We conducted a set of workshops, in particular one that they present is with 11 electronic musicians, because these are probably the early adopters of the musical metaverse, and we asked them, how do you see your composition or your performance or your education practice in the metaverse if by magic the metaverse would be available now? And they told us that in terms of composition, they will use the space, the dimensional space as a novel compositional dimension. They will use the metaverse as a new set of customizable virtual interfaces to support their compositional practices and also their sound design practices, because the goal is to go beyond what is possible to achieve today with real instruments or in general with the current real world tools. In terms of performances, yes, they envisioned the possibility of creating novel artistic formats and novel concept experiences, the possibilities of enhancing the performance with haptics, like we were saying before, or the possibility of tracking gestures, emotions, and behaviors from both musicians and audience members, and repurpose this information in real time to control elements of the virtual worlds. In terms of education, that well, they saw the metaverse as a space where it is possible to learn in different ways. So they really wanted immersive remote learning environments to replicate, for instance, on-site conditions realistically, or for instance, to enhance the learning experience with virtual elements, or again, to create learning simulators, such as virtual classrooms that enable them to analyze music, or even to replicate historical physical spaces. But are we ready for this kind of use cases that are being envisioned by musicians? The answer is no. It's not, because we have hardware and software problems. In particular, the head-mounted displays today are really not supporting the audio acquisition, because they have microphones that are conceived typically for speech, that are therefore they are systems that are bandwidth limited, they have dynamic compression, they have noise cancelling functions, and this is really not suitable for singing or for capturing musical instruments, not to talk the support for external microphones that is totally absent. We don't have audio interfaces that are integrated. It is hard to integrate head-mounted displays with MIDI controllers. Yes, one can circumvent these issues using PCVR, which means head-mounted displays that are not standalone, but they can be connected to PCs. But the future is head-mounted displays, and also these setups are less cumbersome compared to wired setups. And in terms of audio output, well, there are loudspeakers in some of the head-mounted displays, but these are really of not good quality, or at least not sufficiently high quality for what musicians really need. So what we can see is that in terms of hardware, sound is mostly considered as an ancillary component as of today. But also software has problems, because game engines such as Unity and Unreal provide some audio libraries that not to what would use professional practice, such as plugins like digital audio workstations. We can also go to the web, but web audio API needs to be integrated with WebXR technologies, and there is still a scarce availability of guidelines today. Special audio systems are very well, and there are no common standards at the moment, which prevents the fragmentation of the field of 3D audio for XR. So also what we tried to implement some kinds of setups to try to push the boundaries, understanding what are the limits of technologies today. And we created a setup where we have 2 musicians interconnected in mixed reality. They were connected with at the audio level with a network music performance system, and at the visual level via the capturing of a volumetric video via point cloud. And what we found? We found that the audio arrives 400 milliseconds before the 3-dimensional video. And this is totally not acceptable for the experience of musicians. Then we also made our inroads in 5G, and we understood that we needed to understand how to design architectures to support the integration of network music performance systems with extended reality systems, with spatial audio systems into 5G architectures. And as of today, we don't have this knowledge to achieve this, which is a paramount aspect in the musical metaverse. We also understood that even if we want just to tackle audio only integrations of network music performance systems and 3D audio, we need to progress hardware and software on network music performance systems, because these kind of network music performance systems only provided the mix of all the musicians that are connected. But for 3D audio, we need the independent sources to be positioned in the virtual space. And today there are no systems available on the market or in the in academic research that I know that enable this. And there is a complicating factor that integrating spatial audio entails additional processing time, which translates in latency and we conducted some kind of measurements, and we understood that we can arrive by combining various spatial audio systems from different plugins to 0.33 milliseconds. But note that in the context of network music performance system, 0.33 milliseconds amounts to several kilometers. Now, I would like to share a couple of videos, and then I think I can conclude, because I believe I am late, correct? Do I still have some time, Roger and Riccardo?
Yes, let's keep going.
All right, so I would like to share a video of a simulator of mixed reality that enables us to understand what would be the experience if all these technologies, technological issues of playing in mixed reality with the audiovisual mismatch that I was talking before and the latency issues were solved. So this is the vision of the musician. Right. And you could see that there were three other musicians that were playing together with the musician. These three musicians to play together with the guitarist. These three musicians were recorded before, were not playing in real time. But this simulation enabled us to understand that the musicians actually would really appreciate this kind of systems in order to be immersed much more in the musical experience compared to bidimensional videos. But the problem is that also this kind of devices that you can see are pretty cumbersome on the head of the musicians. They are heavy, and the person does not feel really comfortable. Quickly, just to say that we also made our inroads in web audio and its integration in WebXR, and they can share some kind of playgrounds. This is what we could achieve with the current web technologies. We are dealing with multi-user environments on the web, where people can play, can select musical instruments, virtual musical instruments, create sounds, and share the sound, and move also the sound sources in these three-dimensional environments, change parameters, and so on. Or again, we explored the case in which musicians could play and could actually sing together, leveraging the microphone.
Where are you? Oh, yes. Okay.
There is some kind of music information retrieval in real time performed by the web browser.
On my left. You're going from my left ear to my right ear. Hello. Hey. I'm flying.
Right. So, okay, these are trivial examples, but trust me, these are essentially, this is the state of the art today to use it to integrate somehow the musical metaverse on the web browser. So definitely technologies such as WebXR and web audio are not the solution to the main problems affecting network music performance systems and multi-user virtual environments, because we notice that we can't support a large number of concurrent users. There is a latency introduced by the network and by the browser. There is an issue of synchronization of the various virtual objects and entities, and the social interactions are still minimal. But we understood that the web browser provides a set of opportunities that still need to be explored at artistic level. So this is a really active area of research, which is pretty much not explored today. Finally, we also tried to connect all I said so far in a mixed reality concert for audience members that were mixed reality headsets indeed, but also, as you can see in this picture, haptic vests that are controlled by the smart musical instruments used by a band. So this is a recent concert that demonstrates this concept. Right, this was of course a proof of concept. We have other videos about this kind of concept you can find. So let me draw the conclusions. So essentially, the metaverse is emerging as a novel space where collaborative musical activities can be conducted. And this is a vision that promises to redefine how we create music, how we share music, how we enjoy music. There are a lot of opportunities ahead of us that still need to be explored, including business opportunities and artistic ones, of course. But still, we have to solve several technological issues and also non-technological issues. As you have seen before, creating just a realistic experience for just two connected musicians over the internet represent really a significant technical challenge because of the latency and reliability constraints of musical interaction. And current extended reality hardware and software for sound, we saw that fail to capture and render the subtleties and the unique attributes of inherent in musical creation and expression. And there is also the need, of course, to have domain-specific tools that are absent today. And there is also the need for standardization activities. But something I didn't really talk too much before is that, of course, we have a set of artistic issues, ethical issues, sustainability issues, and regulatory issues that we need to address in order for the musical metaverse to be created in the interest of its beneficiaries, such as security and privacy issues, the fact that these kind of systems have a high energy consumption, and also we need to solve accessibility and inclusiveness issues. Of course, to achieve all of this, we needed to conduct research on social interactions involving deeply the end users. I would like to conclude by thanking the funding agencies that have supported and are supporting this kind of projects that you saw before. So the Italian Ministry of University and Research, and then the European Innovation Council. Actually, we have just started since February a novel project called the Musical Metaverse Made in Europe, and here you can check the website. Finally, of course, I need to thank my team, the Creative, Intelligent and Multisensory Interactions Lab. All you saw is not the fruit of my work alone, but is also the work of my collaborators. Thank you very much. If you have any questions, I'm happy to answer. Hello, do you hear me?
Yeah, I'll jump in, Luca. First of all, thanks. That was fantastic, and that's just an amazing body of work.
Thank you.
Yeah, so I'm wondering if you think there's enough. Well, I mean, so I'm thinking about these all of these augmented instruments that are coming out of your lab and many other labs, and we see in NIME different approaches to instruments, but it always seems like they're for the most part kind of one-off instruments. And I wonder if you think there's an opportunity for enough acceptance or standardization or market or something to really develop something that thousands of people, might perform and share over Internet of Musical Things.
Yeah, this is a question that I would like to answer with a positive answer. So I think that musicians have always tried to be on pair with their times, and which means that they always want to exploit the technologies of their time, and the music market needs to follow this trend and is following this trend. The Internet of Musical Things and the smart musical instruments represent paradigm that today are just at the beginning. So they are just emerging in these years. Like at the time of Bach, Johann Sebastian Bach, there were technologies that become widespread only dozen of years later, and so the history probably repeats itself. I'm positive because for a single reason. Now we live in a world that is interconnected. We are always connected. We are always online, connected every time with anybody, everywhere, and so on. And also music is following little by little the same trend. And also there is a lot of attention, I think, by musicians to avail themselves of novel tools to express themselves, to create, to share music, to interconnect, to interact with their fan base. So I'm pretty positive, but let's see what are the directions that the market will pursue in the next years.
Yeah, thank you.
Are there any other questions?
Yeah.
That was a very comprehensive presentation. Thank you. Do you have any idea how long it will take that chart that said no to a yes?
How long will take it to accomplish this vision and go to the market?
I mean, do you think this can be done in less than 10 years?
No, In this presentation, I talk about the two main components, the Internet of Musical Things and then its evolution in the musical metaverse. I have to say that some parts of the Internet of Musical Things are already a reality. So, for instance, the network music performance systems are becoming more and more widespread, have been extremely used during the pandemic, especially relying on systems based on these embedded devices. Concerning the musical metaverse, this is really, we are still really at the beginning of this
Okay,
history. So I
I just
don't
was curious on what you think. That's
I
all
don't
right.
think that in 10 years the musical metaverse will be accomplished as I have as it is at least envisioned by these big giants, big tech giants such as Meta and so on. We still have to progress the networking infrastructure. We still need to have tools, in particular hardware tools that are affordable and that can be widespread and do not cost too much, and at the same time enable the performances that are really needed to achieve this kind of real-time interactions. Let's see, because then it is difficult to forecast the
I think
future.
you answered. I think you answered it. It's going to be a challenge.
It's pretty much a big technical
It was
challenge.
great presentation, though.
Thank you.
Okay, I have one question. So here at Carnegie Mellon, a few months ago, we had a performance using the Yamaha disc clavier. And it was a virtuoso performance, both for the pianist, the live pianist who was playing, and for the instrument itself. So I guess my question is, what happens? I mean, what I like the most is see a virtuoso player using technology in an interesting way. What happens if we change the whole parameters around and people don't have to learn their skills in guitar, in piano, and violin, those traditional instruments? What happens if we forget about those skills that have, take such a long time to develop and just go to electronic and virtual and automated instrument sounds? Is that going to happen, or are we still depending on the virtuoso live musician?
Yeah, thanks for this question, because it's a really important one. So, of course, I am a researcher and I try to push the boundaries of knowledge and try to explore novel avenues for artistic expressions. But I come from a tradition of conventional musical instruments. I play the bagpipe, I play medieval instruments that are now present in the folk tradition of the Little Valley in the pre-Alps where I come from. I play the mandolin, which is the hurdy-gurdy. I play the mandolin. I am graduated in classical guitar. So I don't think that people will ever lose the passion for playing real instruments that provide tactile feedback and a visceral also interaction with the instrument itself by the musician. But there is a risk, in my opinion, coming with AI, with all these automation, we call, and generative music, where everybody becomes a musician just by pressing a button. There is a risk of a cultural impoverishment, in my opinion. But at the same time, I don't think that musical instruments, as we know, the conventional musical instruments, will ever be forgotten in place of purely virtual musical instruments. Purely virtual musical instruments and AI based musical instruments can have a future, but real musical instruments, I don't think will ever disappear. Let's see what will be our take as a society. Is not something that technologists will decide, or the market of the industry manufacturers will decide. It's something that we as a society will decide, will our shifting needs and the needs that every human being and every musician had in relation to his or her times. I don't know if I have answered satisfactorily this question.
Yeah, well, anyway, that's encouraging to hear. I know for me, I've always wanted to find the instrument that you didn't have to actually practice to be really good at, and it would sound good. But I don't want to hear anyone else play that instrument. Are there any other questions? Okay, well, thanks again, Luca. It was nice to meet you, and I hope we can keep in touch over these things.
Yeah, thank you very much. And of course, I'm happy for collaborating with you, with your team, with your students. We are welcoming students in my laboratory if you want to visit us and spend a period at our premises. And if you want to follow us, our developments of the Musical Metaverse Made in Europe project, here is the website. You can subscribe to our newsletter. Right. Thank you very much.
Thank you. Arrivederci, a presto.
Thank you.
Thanks.
Bye.
Bye-bye.
Bye.